Okay, I lied. In your last video, I said this would be the last one that I make in these same clothes, and I was wrong. So if things worked out like we planned, you probably just took a quiz on lessons 1, 4, 5, 6, and 7, except not 7. We didn't do 7. So 1, 4, 5, and 6. And we just finished off with that coordinate plane. So here we are again in our coordinate plane. So what this problem is saying is that triangle ABC has been dilated by a scale factor of 1/2. Remember, when the scale factor is less than 1, it is called a reduction because we know it's going to be smaller than. And we can see that. Here's ABC. Here's A prime, B prime, C prime. It has gotten smaller. We have also noted that, or we also have triangle A double prime, B double prime, C double prime, which is congruent. So these are exactly the same. So what we're trying to figure out is what sequence, and you've seen the word sequence before with our rigid transformations, would map the triangle onto triangle AB double prime, B double prime, C double prime from this one. So there's 2 steps that need to happen. We can't go from this to this. So the first step that needs to happen is we needed to dilate it. So step 1, I would say dilate by R equals 1/2. And remember, I abbreviate scale factor as SF. Engage New York does not. They abbreviate it by R, which is fine. So that's the first step. We are dilating it. It's a reduction if we want to be very specific. And I'm freezing, so I'm going to keep drinking coffee. Step 2, and this is our sequence. We are now going to do what? How do we get this figure over here? Well, exactly like what I just did. We're going to translate. And to get A to here, I'm going to translate up 1. I'm going to translate up 1 point and to the right. Let's see how many. So I translate up 1 over 1, 2, 4, 5, 6, 7, 8, 9, 10. And if I do that with every single one, B goes up 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're all going to translate onto that figure. So we cannot forget our rigid transformations. Remember, translate is slide. Reflect is that flip, and our rotation is our turn. So that's pretty easy. What does this have to do with similarity? Well, remember, similar figures, this is from lesson 1, similar figures have the same shape but different size. Okay? So this was not a rigid transformation because it changed size and then moved. So what else do we have here? Let's see. Ugh. I hate that my keyboard's broken. Okay, so now we get to this guy. Oh, this guy. So triangle ABC, where's my mouse? There it is. Triangle ABC was dilated from center 0, which is our origin. And it was done by a scale factor of 1/2 once again. 1/2 reduction because it's less than 1. The triangle dilated is noted by triangle ABC prime to double prime. Describe the translation. Okay, so we first have to say step 1. We're describing the sequence. This should be the easy part. Dilate by R equals 1/2. Plain and simple. It shrunk down, it comes to here. That's the easy part. Step 2, well, did it rotate? No, B's still at the top, A's still here. So how do we move this? We translate. Okay, so B's up here. I need to get it down 2 spots. Translate down 2. And once again, to the right. How many? Let's find out. So down 1, 2, over 1, 2, 3, 4, 5, 6. And that's how I'm translating it. I'm counting it by the points rather than saying a vector. Because when we're on that coordinate grid, we want to talk about points being up and down and left and right. Hopefully there's no questions so far, because if you do, you can't ask them anyway. You're on video. Moving on. I think we're getting to the fun stuff now. No, I don't like that one. Actually, yes, I do. This is the fun stuff. Okay. So first off, describe a sequence that would show that triangle ABC is similar to triangle A prime, B prime, C prime. So now we're trying to show the transformation talk about the dilation and prove it. So first off, I need to count. Before that I can say this goes to this, let's start with, remember, our pre-image. Our pre-image is the one without the primes. So from A to B is 2 spaces. From B to C, 1, 2, 3 is 3 spaces. I'm only worried about that. Because what I need to do is find my scale factor. And remember, it's AB prime equals R times my pre-image, which is AB. So right now, we've got R times 3 if I'm doing BC. So let's find BC. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, how can I find my scale factor? First off, did it get bigger? A, B, C, A prime, B prime, C prime? It absolutely got bigger. So I divide both sides by 3. R equals 3. Okay, well that's using, I wrote this wrong. I'm sorry, kiddos. It's not AB. I used BC. Could I check it though with AB? Because it better have the same scale factor. So let's check it. So we already know AB is 2. Let's try AB down to A prime and B prime. 1, 2, 3, 4, 5, 6. So this is 6. So I've got 6 equals R times 2. I divide by 2. Holy moly, it gives me the same scale factor. So I know these are similar because they have the same scale factor. The scale factor has to stay constant. So immediately, step 1 to describe this is I dilate by R equals, and we're going to come with 3. So I had to find that scale factor. We found that scale factor by counting. You might be saying, Mr. H, why didn't I count the diagonals? Because there's not full diagonals to count. We try to stay away from diagonals as much as possible on the coordinate grid. So, step 2, though, is what? How did we get this figure where BA was pointed up to where BA was now turned to the left? So now it takes a little bit of remembering where we rotate 90 degrees, which direction? Oh, counterclockwise. So they're asking for a lot of stuff here. They're asking you to find a scale factor, and they're asking you to find what rigid transformation needed to happen after it got dilated. So the question is, if I'm dilating it by a scale factor of 3, which is bigger than 1, what type of dilation is it? Well, if it's not a reduction, it means it's got to be an enlargement. Remember, when our scale factor is greater than 1, it's an enlargement. If it's smaller than 1, it's a reduction, reduces. Why can't I find the rag? Kiddos, it's a good day. This is video number 5 for the day. That's a lot of work. Proud of that. Getting ahead of things. Here we go, here we go, here we go. Oh, man. Are the 2 triangles shown below similar? If so, describe a sequence that would prove triangle ABC is similar to triangle A prime, B prime, C prime. State how you know if they're not similar. The key to similarity is they all have to have the same scale factor. And we did this last year. We did this in 7th grade math. So AC, AC. You have to find corresponding parts, corresponding in the same place on the other figure. But we're worried about the letters. So here's my original. Remember, it's image equals R, which is my scale factor, times pre-image. So my pre-image is 18. We don't know what R is. That's what we're trying to find out. And my image is 12. So I'm going to divide by 18 from both sides. So now I've got 12/18 equals R. Is this really what I want? Absolutely not. We need to simplify the fraction. I know that 6 goes into both. So I divide both by 6. R gives me 2/3. Well, what is that for? That's only for AC. So for AC, it's 2/3. We need to check all of the sides. So now let's try BC. So now I've got R times 6 BC, B prime, C prime. 4, divide both sides by 6. Well, 4/6 can be divided both by 2. Have to remember the multiples. That's going to give me 2/3. Oh, man. So my scale factor so far is 2/3 for both. but we have to check our third side. Just because the two sides work, we don't know, but hint, 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 if two sides have the same scale factor, so will the third side. But we're not there yet. So we're going to check. AB this time. AB is 15 times R equals AB, which is 10. Divide by 15. That leaves me R equals 10/15, which again is not simplified. We need to divide by 5. And that once again gives me 2/3. Notice how all of the sides have the same scale factor. Because they have the same scale factor, that means these are similar. I haven't even answered the question yet. So are they similar? Yes. Now we need to describe what happened. So we dilate. So step 1, dilate by R equals 2/3. That's first. This was my pre-image. This is my image because of B prime. Then, so it just got smaller. Then what? We could say it rotated. We could say a bunch of things. We could say first it translated and then rotated, but I'm just going to go rotate. And if there's a point here, I'm going to say it rotates 180 degrees because it's pointed the other direction. I like that none of these examples are in my book. Phew. So we're there. This takes us to our lesson summary, which I'm going to read to you because I'm not worried about that example. So a similarity transformation, remember transformation means that we're moving it, is a sequence of finite dilations. Finite just means there's a set number, and basic rigid transformations or motions. So two figures are similar if there's a similarity transformation. Remember, similar means same shape, possibly different size. Okay? You need to find the scale factors. That's the key. And to find the scale factor, just like it's been since the first day. I think this was from day 1. Image equals, and I call it scale factor, so that way you know what it is and not just R, times the pre-image. And remember, the pre-image is the first image without R primes. You're welcome. Hope you have a good day.